So in this video, we will learn if the given differential equation, basically first order higher degree differential equation, is in this form, means y equals to px plus any function of p. This format means this type of equation is known as Clairaut equation. Then we can easily find the solution. So in this video, I will explain Clairaut equation. Okay. So any first order higher degree differential equation, we can modify this equation in this form: y equals to px plus any function of p. Then first we have to derivative this equation with respect to x. So it will be p equals to p plus x into dp dx plus f dash p dp dx. Okay. So from both sides, this p will be cancelled out. So if we take dp dx common, so it will be dp dx in bracket x plus f dash p. Okay. So now from this equation we can say that either dp dx equals to 0 or this x plus f dash p equals to 0. Okay. So now from this equation we can write dp dx equals to 0 in this form, dp equals to 0, and if we integrate both sides, it will gives us p equals to c. Okay, so from this equation we get p equals to c. Okay, now from the equation 1 and from the equation 2, if we eliminate p, then it will be y equals to cx plus f of c, which is known as general solution. Okay, but if we eliminate p from the equation 2 and 3, then we will get an equation of xy, and this equation is known as singular solution. Okay, in mac out, if you check the previous 10 years question, the maximum time they asked from this section that find the general solution and singular solution of the given differential equation. Now try to understand this method with an example. Okay, so there is a differential equation y minus px p minus 1 equals to p. Okay, so here we have to obtain singular solution. So before finding the singular solution, we have to find the general solution. Okay, so first try to modify this equation. So this equation, we can write this equation in this form: y minus px equals to p by p minus 1. Okay, so this equation is y equals to px plus p minus 1. So we can say that we can write the given equation in the form of y equals to px plus any function of p. Okay, now it's basically the Clairaut format. So if we differentiate this equation 1 with respect to x, it will be p equals to p plus x dp dx minus 1 by p minus 1 whole square dp dx. Okay, so from both sides, this p will be cancel out, and if we take dp dx common, so it will be dp dx x minus 1 by p minus 1 whole square. Okay, so from this equation we get one solution of p. So dp dx equals to 0 implies p equals to c. Okay, and from this equation x minus 1 by p minus 1 whole square equals to 0, we can write p in this format: p equals to 1 plus square root of x divided by square root of x. Now, if we eliminate p from the equation 1 and 2, so we can write because value of p is equals to c. So in the place of p, if I put c, it will be y equals to cx plus c by c minus 1, which is our general solution. Okay, but to obtain singular solution, we have to eliminate p from 1 and 3. Okay. So now the third equation is p equals to 1 plus square root of x divided by square root of x. So in the place of c, if you put the value of this, because c equals to p and p equals to 1 by square root of x divided by square root of x. So just put the value of p here. So we will get this equation, x minus y plus 1 whole square equals to 4x, okay, which is known as singular solution of the given differential equation. Okay, this is not general solution, it's known as singular solution. Okay, so in this way, try to find the singular solution and general solution of this equation. Obtain the general solution and singular solution of the equation y equals to px plus square root of a square p square plus b square. Okay, so pause this video and try to find the solution. So the given differential equation is y equals to px plus square root of a square p square plus b square. So we can say that the given equation is in the form of y equals to px plus any function of p. So we have to differentiate this equation 1 with respect to x. So it will be p equals to p plus x into dp dx plus 1 by square root of a square p square plus b square, a square 2p dp dx. Okay, let me write this, a square 2p dp dx. Okay, and there will be another 2 is here. So 1 by 2 square root of a square p square plus b square into 2a square p dp dx. Okay, now this 2, we can cancel this 2. So if we take dp dx common from this 2 term, because this p will be cancelled out, so we can write this equation in the form of dp dx in bracket x plus a square p divided by square root of a square p square plus b square equals to 0. So now from this part, means either this value is 0 or this value, it will be 0. Okay, now so if I write dp dx equals to 0, so it implies that p equals to c. Okay, and eliminating p from the given equation and the equation 2, we will get our general solution. Now if I want to find the singular solution, we have to eliminate p from this equation and the given equation. So here we get x plus a square p divided by square root of a square p square plus b square equals to 0. Okay, now here the value of x, it will be minus a square p square divided by square root of a square p square plus b square. Okay, now if I want to eliminate p from 1 and 3, so it will gives us y equals to minus a square p divided by this plus the value of this value is a square p square plus b square. If you simplify this, it will be b square divided by a square p square plus b square. Okay, now from this equation, let me take its equation 3. Now we can write this equation in the form of y by b equals to b by square root of a square p square plus b square. Okay, now again we can write this equation also, x by a equals to minus ap by square root of a square p square plus b square. Okay, now if I square both sides of this 2 equation and add this to equation. So it will be a by x whole square plus b by y by b whole square equals to minus ap by square root of a square p square plus b square whole square plus b by square root of a square p square plus b square whole square. Okay, so if we simplify this, it will be cancel out and we can say this value is 1. Okay, so basically from this equation we can write a square p square divided by a square p square plus b square plus b square divided by square root of a square p square plus b square, and it will be 1. Okay, so this is our required singular solution of the given equation. Okay, so in a similar way, try to solve this equation. Find the general and singular solution of the given equation. Given equation here is py equals to p square x minus b plus a. Okay, so first we have to modify the given equation in that Clairaut format. Okay, so we can write the given equation in the form of y equals to px plus a by p minus bp. Okay, so if we differentiate this equation 1 with respect to x, it will be p equals to p plus x into dp dx minus a by p square dp dx minus b into dp dx. Okay, so from both sides we can cancel this p, and if we take this dp dx common, it will be dp dx x minus a by p square minus b equals to 0. Okay, now we can say either dp dx equals to 0 or this factor is 0. Okay, so if I take dp dx equals to 0, it will gives us p equals to c. Okay, and from the equation 1 and 2, if we eliminate p, it will gives us the general solution. Okay, now from this equation, from the other part, we can say that x minus a by p square minus b equals to 0. So from this equation we can say p equals to square root of a by x minus b. Okay, now we have to eliminate p from the equation 1 and 3, which actually gives us the singular solution. So let me write the given equation. Okay, so if I eliminate p from the equation 3 and 1, so this is our equation 1, we will get singular solution. Okay, so we already get the value of p, just put the value of p here. So here we can write this equation in the form of py equals to p square x plus a minus b p square. Okay, because the value of p square is a by x minus b. Okay, so just put the value of p and p square in the equation. So it will be square root of a by x minus b equals to ax by x minus b plus a minus b into a by x minus b. Okay, so in this way we can find the general solution and singular solution. So I think it's very easy to calculate. You can just simplify this in this way, that ax plus ax minus ab, and here this value is ab. Now just let me take the square in both sides. So it will be a by x minus b y square equals to 4 a square 1a is cancel out. So this is basically y square equals to 4a x minus b. So this is our singular solution of the given differential equation.